Hello everyone, I'm going to be explaining some application questions for linear lines here. I'm together with my favorite class, Myp3C. Myp3C, say hi to your future selves!
Hi, future self!
Future self 6, 7.
Alright, let's start. So, this question is about a online bookstore. Bookstore A is what we'll be looking at first. They sell a certain book for $18 and it charges $50 for delivery. From the information state the fixed cost and the variable cost. So fixed means it's set, it's fixed in place, it doesn't change. So if we look at these costs, a textbook costs 18 for one textbook. So if I buy more textbooks, that will still change. But 50 for delivery, they're always going to be delivering no matter how many books I buy. So that 50 is fixed. So the fixed cost is the 50 amount. And the variable cost is the 18 amount. Then let's complete the table to show we know what we're doing. If I go buy no books whatsoever, I still need to pay that fixed cost of 50. Then if I add one book to it, I add 18, so we get 68. And then we add 18 again. Class, what do we get if we add 18 again?
84.
84?
86.
86.
Wait, sir, if you have 0 books, if you buy 0 books, then how is the delivery 50?
That's a very good question. You get an empty box, cost you 50 bucks.
Yes.
Yeah. All right, so we add 18 again. What do we get?
104.
104. We add 18 again. What do we get?
122.
122. And next up?
140.
And then we get?
130.
30.
410.
Come on. So we add, oh, sorry, it's 10. I wasn't looking. Yeah, we add 10 times 18. This is actually a good question to do in a bit more detail. We see we have the fixed cost of 50 plus 10 times 18. So 180 plus 50, giving us
220.
230.
410.
And then once again, if we do it for 20, 20
410.
410.
plus 20 times 18. What do we get?
410.
410. Yes, very good. Is there a linear relationship here? Yes. Yes, very good. Yes.
Plus 18.
And we can...
The number of books, you add 18.
Exactly. Every time we add one book, we add $18. So there's a linear relationship. If you add one book, you add 18. Add one book, add 18. Can we get some silence for the video, please? Thank you. If you add one book, price goes up by 18. So that 18 is what we call the
variable.
not the variable, the what, the slope or the gradient.
Rise. The rise.
It's a rise over run, it's the gradient or the slope. Yeah.
Wait, sir, do you need it?
You don't necessarily need to add it, but every linear line has a gradient. So if you find that your equation has a gradient, it's a nice way to show that you can see it's linear. Because every time we can do a plus 1 for the number of books, we do a plus 18 for the order. And it stays consistent. Even here, if I add plus 5, well, that means I'm just adding 5 times 18. So if I add one book, I add 18. If I add 5 books, I add 5 times 18. The ratio stays the same. So moving on, determine the rule, the equation. We've done this a lot of times. For a linear equation, we have mx plus c. In this case, what is the m value?
18.
18. And the c value?
50.
Very good. Use your rule to work out the cost if you order 35 books. Well, in that case, x, the number of books, is 35. Now we add 50. You all have done this as your homework, so please tell me what's the outcome to this question?
680.
680?
Yes.
Good job.
107.
Now, I got a very good response just now from the class saying $680. We're doing a real life application, so don't just leave your answer as 680. Make it in terms of, well, the context. We're talking about how much does it cost, what's the cost. So you add a nice conclusion. It costs $680.
Does this give you a better grade in D?
So this is for communication by writing a conclusion. It's for criteria D, real life application, by mixing it with the dollar amount, by introducing that dollar sign. How many books can be bought for $800? Okay, so now I want the price to be 800, where I have the equation 18x plus 50 still from before, right? It's the equation we had right over here.
Minus 15.
So we subtract 50 on both sides. And then what we get is 750 is equal to 18x. So divide both sides by 18, very good. Divide by 18. Divide by 18. So what we are left with is, well, what is 750 divided by 18? 41.6 repeating? Is it really?
No, 41.6666667.
So if we were to round,
Yeah, but if we would have rounded.
if we were to round it, well, let's have a look. 41.666, etc. forever. How many whole books can you buy for that? 41, right? I can't buy 0.666 book. So I'm going to say,
Come back 42.
so you can buy 41 books. Because that's what the question was asking. Okay, plot the graph to show the cost of the order of the bookstore. Make sure you label your axes. Okay, let's start by labeling our axes. And actually, I'm going to look back to the table from before to see what type of numbers we are dealing with. I'm seeing for the order of books, I have 0, 1, 2, all the way up to 20. So I'd like to be able to see all the way up to 20 in this graph. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 of those spots, so maybe a nice scale would be steps of 2. Yeah, very good, Kata. Steps of 2. So this way, if we do it, we will make sure that we can put even the 20 value in our nice graph. Okay, so what was the variable? X was the amount of?
400 and
X was the number of? Books, yes. So X, it's the x-axis and it's the number of books. And then what values were we looking at when it came to the y-axis? The highest one is 410. So maybe let's see how we're going to do this. How many steps have I got? Is it 10 steps as well? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I also have 10 steps. Maybe I'm doing it in terms of, I'm going up to 500. So 50 each. 50, 100, 150, 200, 250, 300, 350, 400, 450, and finally 500. And this is my y-axis, and y was the
cost of the book.
the cost. Yes, it's the cost in dollars. Okay, now let's plot some of these values from my table. I had the value 0, 50. That's a very nice one because I can clearly read off the 50 amount. And I'm going to do another nice number, 5 and 140. So let's start with those. 0.50. It's right over there. 5, and what did I say? 140. So 1, 10, 20, 30, 40. So I put the dot right over there. And then, actually, let's do the 21. We went all the way up to 20, so let's use it. 20 was 410, if I'm not mistaken. So with those 3 points, I should be able to draw a nice straight line. There we go. And now what do I not forget? What do I need to do with this line?
Label.
Label. So this is a bookstore A. And this whole graph is displaying the price depending on books. Okay, so I've got a nice graph here. In a moment we'll see we are going to add something more to it. So let's go down and look at, there's a whole other bookstore, bookstore B. Let's have a look at bookstore B. It's very similar, but now we have $20 per book, and they only charge $5 for delivery. So nice of them, yeah. So if we order no books, it costs $5. If we order one book, we have 25, 45, and then we have 65, 85, 105. And then if I have 10 books, that's 10 times 20 is 200, add 5 for delivery, 205. And if I have 20 books, it's 405. Determine the rule. Okay, so we can do this quickly. We're doing the same thing here. Y is equal to my gradient, set the variable cost, 20 times X, plus my shipping fee, $5. Use your rule to work out the cost of ordering 35 books. So once again, we're substituting 35 plus 5. What do we get here? Anyone? Yell it out. What's the answer?
Don't you know, sir?
705. What do I need to add still? Is this correct? Well, it is correct.
$705.
It's $705.
Dollars indeed. It's a dollar amount, the cost. So it costs $705. How many of the books can be bought from 800? Well, similarly to the previous time, we're going to be solving it like this. 20 times X plus 5. I'm subtracting 5 on both sides. So we get 795 is equal to 20x. I need a bit more space, so I'm going to continue right over here. What do I do on both sides now?
Divide
by 20.
We're dividing by 20. Yes, I'm doing divide by 20 on both sides. Then we are left with x is equal to, one more time? 39.75. So how many whole books can be bought?
39.
So 39 books. Plot the graph in the same grid above. Okay, so let's do that. 20x plus 5, so we have 0, 5, that's our y-intercept, so let's start there. And let's end with 20,405. So 0, 5, that's quite a low starting value. But then we end with, what's our final value? 20,405. And our previous one ended with 2410. So just slightly below there, as you can see. So let's connect these up. There we go. And this is roughly the line. Let's not forget to label it. Bookstore B. Okay. Now, if we go back to the questions here,
Who's Miss Relu?
Miss Relu is not a very nice math teacher at this school. Miss Relu wants to order textbooks for her classes. She needs 25 textbooks. Which bookstore should she use? Okay, let's first look at the graph. 25. Ooh, 25 is not on the grid that I drew. So maybe if I've chosen a different scale, I would have seen 25 on it, but here I don't. So what can we do? We solve a simultaneous equation. Very good. Now, I would recommend that if you are able to see it on the graph, you actually use two methods. You can look at your graph and say, here they intersect, so they're equal. Here's x equals 25. Let's look at which one is lower. So when you look at just the graph and you can see your value on there, please use it to verify the answer that you might find by using algebra or the other way around. We'll come back to this in a moment when we discuss the criteria rubrics. But for now, we're going to indeed use simultaneous equations. So, no, actually, we don't need simultaneous equations. We're not looking for when they are equal. We're looking for when we buy 25 books. So,
Yeah, you use the equations you made for A and B.
so what's the equation for A again?
Y equals 18x plus 50.
18x plus 50. Okay, so then we would get the cost of, well, 25 books. So 18 times 25 plus 50. If we plug that in our calculator, what do we get as a cost?
25 times
500.
500 exactly. 500. $500.
now for B.
Okay, now we do it for B, and I seem to have switched colors here, but we can probably fix that.
You can't.
Can I not? You haven't seen my full power. Boom, there we go, it's red. Okay, let's do bookstore B in blue now. Also, very nicely, if you in your investigation make use of colors to clearly communicate what's going on, might be nice. We had the equation. It was quite a different one, this one. 20x plus 5. Okay, so now if we have 25 textbooks, we have 20 times 25 plus 5.
505.
$505. Oh, it's close. But which bookstore is cheaper? Yeah. Yes, one moment. So 500 is less than 505. So A, or bookstore A, I should say. Bookstore A should be used, because that was the question, remember. Which bookstore should she use? Always answer the question. She should use bookstore A here.
Are we gonna get like inequalities in our test or no?
What?
It's not really an inequality, it's just me writing down how I compare these values, but without writing the inequality sign, you can still say that 500 is less than 505. Yeah. Explain what a buyer should take into consideration when they decide which bookstore to use. Give reasons for your answers with evidence.
I have a question for the other one.
Yeah, have a question.
When you use this simulate
No.
that thing,
Simultaneous
yeah,
equation?
simultaneous or this?
So we're actually going to be using it for question G, because now we want to know, one moment. So let's have a look at question G. How do you decide which bookstore to use? Well, we would like to know when they have the same cost amount. So when those two lines we saw earlier, if we were to extend both of these lines, you'll see that at some point they will intersect each other. Like I can continue these lines and we'll find a point where they're equal in cost. We're looking for that point right now. So how we do that is we solve with simultaneous equations. This might take a little bit more space. I'm gonna, we'll just see if we can fit it in. So the two equations we had were the one for bookstore A.
18x plus 50 and equals 2.
And the other one was?
20x plus 5.
Right, I want to know what happens when they're equal. So I'm going to actually put them together with an equal sign. 18x plus 50 equals 20x plus 5. So to solve a simultaneous equation, we make sure we bring all the variables, the x parts to one side of the equal sign, all the numbers to the other side. So let's start by subtracting 18x on both of these sides,
Giving us
giving us 50 equals just 2x plus 5. And then let's subtract 5 indeed from both sides, giving us 45 equals 2x, dividing by 2. That will leave us with 22.5 equals x. Okay, so I know some interesting things here. 22.5 books is when the books store are equally expensive, but we're never buying 22 and a half books. So what I can say, for 22 books or below,
store
which one is cheaper?
B.
A.
Well, let's have a look at our graph, shall we? In the beginning, the B bookstore was cheaper. Store B is cheaper.
What are you doing?
So for 23 books or more, yeah, very good. Store A is cheaper. Now, like I said in a previous class, this is the most important part. Like, this is me using math, giving a reason, giving evidence. But there might be another argument that we could add. We don't know much about these bookstores, but does anyone have? Yeah, David?
For example, if you get parallel lines, do we just say that it doesn't matter from which bookstore you buy?
It's a very, very good question. If we get parallel lines, does it not matter? Well, actually, it's the opposite that we see. I really like your question, David. If we were to have a parallel line, let's add a parallel line here in yellow. If we compare this red line to the yellow line, it doesn't matter how many books you buy. You might buy 1,000,000. The new bookstore, the yellow one, will always be more expensive. So actually there's no reason to ever go with the yellow bookstore in this case. So they'll probably not be parallel, because that's not a very interesting question. Finally, any other arguments why you might want to consider one bookstore over the other? Yes?
The books are better quality and ones.
Yeah, a very good suggestion. Maybe one bookstore has better quality, or maybe better customer service. Maybe they offer longer warranty. These are things that we don't know about, but that might influence someone's choice. So when it comes to explain what a buyer should take into consideration, it's something to take into consideration. What we just did was giving evidence. Like, this part is probably the most important for 90% of the buyers, just knowing what is cheaper. And we gave evidence to show why that's the case. But into consideration, you should take maybe indeed the quality of the books that or the customer service of the store. Might be nice to add one line about that in your answer as well. So you might also consider the book quality, customer service, Or, I don't know, Google reviews. If one bookstore has very good reviews, maybe you spend a little extra to buy from there. Don't add more than one line about this because it will blow up your assessment.
Are you like muting it?
So let's have a look at the descriptors for a CD investigation to see what we need to pay special attention to. So first off, criteria C is all about communicating. So appropriate mathematical language we saw in this investigation. Well, we might be referencing, since we're doing linear equations, we might be referencing words like gradient, or maybe words like y-intercept, or intersection.
How could you use that?
So maybe when we come up with the equation, when we use the y equals mx plus c, I said m is the gradient and c is the y-intercept. Maybe it's something where you can write down like, hey, we know from the equation this is the y-intercept, this is the gradient. Use appropriate form of mathematical representation. So make sure you use your y and your x correctly. If you round an answer, you actually use the approximately symbol.
Or the plus minus.
Yeah, moving effectively between different forms. Well, what different forms did we see here? We saw equations, we saw tables, and we saw graphs. If those all match up nicely, let's make sure that you can move correctly between the forms. Your lines need to be coherent and complete, meaning that you actually explain your work. You end it with a conclusion, and you don't scribble all over the page, left, right, up, and down. It needs to be in some consistently organized structure as well. And if you write a full essay about why you should consider one bookstore over the other, that's not going to be very coherent because it's just going to be super long. So stay a little bit concise as well, please. Then criteria D, if you want to score high there, identify some authentic real life elements. So that actually went back to what we ended with. Maybe you talk about the Google reviews, or you talk about the quality of the bookstore, or maybe you mentioned something about people wanting cost to be down. Select appropriate strategies to model the authentic real life situation. Well, in our case, the strategy was to use linear equations and to find the intersection, or to find when one is cheaper for a certain amount of books. Apply those strategies correctly. Basically, this means, can you select correct maths? Can you do the maths correctly? So there's an element of, can you actually do the maths in a math test? I know, crazy. And then, can you explain the degree of accuracy of the solution? This is something that I would have wanted to do, but unfortunately this question didn't really leave me room for. Remember when I said you can use a second method? You can either look at the graph, what's happening for 25 books, and you can then also use algebra to find it out. If you do both, you can discuss the accuracy. You can say, hey, I've done my algebra and I found the answer 22.5. And I can also see in the graph it's 22.5. Therefore, my work is probably accurate. That's a very good way to explain the accuracy of your solution. Almost. Final point. Explain whether the solution makes sense in the context. Ooh, we didn't really go into this, so I must say probably I wouldn't have a good criteria D grade. I would have to add something like, does it make sense that 22.5 books is the cutoff? Well, it's not very unrealistic that a teacher would buy 22.5 books. It's a realistic amount for a class that you might want to consider one bookstore over the other. Something like that could work here. And that is the end of this video. I hope you enjoyed. I hope you'll watch it later, all of you, to study well. Subscribe, like, and just especially for share. Especially what?
Down below.
Post notifications on.
Copy down below.
Comment.
Oh, comment. Yeah. Make sure you comment. If you like this video, please comment. Comment a specific number. What number should they comment if they like the video?